Welcome to our channel, my dear students. Today we are going to talk about the very important topic in organic chemistry, naming reaction. That is in part 3. So here which we are going to discuss these reactions. Okay, let us discuss one by one. So here, first reaction we discussed about that Gattermann's reaction. What is a Gattermann reaction? The Gattermann reaction is nothing but when benzene diazonium chloride will be taken and we are going to react it with copper powder with HCl. I'll be getting chlorobenzene as my product along with nitrogen gas evolution. This reaction is almost similar to Sandmeyer reaction. So in this case also we used a copper chloride. So from benzene diazonium salt to copper chloride, if you add, you will get chlorobenzene. Likewise, here also the same thing, same benzene diazonium chloride, and instead of that copper chloride, if you use copper powder, that reaction is otherwise called as a Gattermann's reaction. I think so you understand well. So here from benzene diazonium chloride to copper powder with HCl, I will be getting chlorobenzene as a product. That's the first reaction. And second one is a very important one reaction that is called a Kolb reaction. What is a Kolb reaction? So here it is nothing but when phenol will be taken, that is reacted with a base like sodium hydroxide. So here the sodium hydroxide will come and attack like this to form sodium phenolate. Sodium phenolate as a product. So this sodium phenolate, which is going to react, sodium, not to be phenolate, sodium phenoxide, I think so, yeah. Sodium phenoxide, which is going to react, and at the temperature of 400 Kelvin and 4 to 7 atmosphere, if you pass carbon dioxide, you will be getting the product sodium salicylate. Sodium salicylate as a product. If you hydrolyze that sodium salicylate, you will be getting salicylic acid. You'll be getting a salicylic acid as my product. So here is nothing but the phenol will be taken, that will be reacted in presence of aqueous sodium hydroxide. Here you'll be getting formed sodium phenoxide. That sodium phenoxide will be undergoing the reaction at the 400 Kelvin and 4 to 7 atmosphere. By that way, I'll be passing carbon dioxide gas. I'll be getting sodium salicylate as a product. If you hydrolyze this or if you acidify this, you'll be getting salicylic acid as a product. That's the second reaction what we are going to talk about today. And next one is Reamer-Tiemann reaction. It's a very, very simple one. So here, same phenol will be taken and the chloroform will be taken and that will be mixed with aqueous NaOH at the temperature of 340 Kelvin, which gives this kind of intermediate product. If you hydrolyze this, I'll be getting salicylaldehyde. So in that case, in previous case, we discussed about the salicylic acid. But in this case, we are going to discuss salicylaldehyde. In this case, what is that? So if you use a Kolb reaction, you will be getting salicylic acid as my product. Salicylic acid as my product. But in the case of a Reamer-Tiemann reaction, you will be getting salicylaldehyde. So here, if you want to, here the trick is, we have to find out the trick between these two. So just is nothing but a Kolb reaction and Reamer-Tiemann reaction, you just compare it. So reactants are same, almost reagents are almost same. So here instead of that carbon dioxide, if you pass carbon dioxide, COOH, I'll be getting. If you pass CHCl3, if you add CHCl3, so CH, one more O is added to that, I'll be getting benzolate as a product. Here COO is added, carbon dioxide is added, that's what I'll be getting COOH as a one of the product. Are you able to understand? So here CH you are going to add CH, it's a trick, CHCl3, that's what I'll be getting CHO. So here it is nothing but COO, that's what I'll be getting COOH. Okay, by the way of using this trick, you can able to differentiate this Reamer-Tiemann as well as Kolb reaction. And next one is Williamson synthesis. It's a very, very important ether synthesis. Williamson synthesis. So here it is usually or particularly we are going to synthesize the unsymmetrical ethers. Unsymmetrical ethers in the sense what? So in as you know that O is a ether functional group. So in that ROR, if I'm using RO as a product, suppose if I'm taking R, here it is O, here it is R. This is nothing but our ether. So here this R, so instead of that right hand side one R is there, left hand side one R is there. If both are different, if I'm having one number of carbon atom containing R, that is methyl group. Suppose if I'm containing 3 number carbon containing group, that time will be called as R dash. So both are different at that time, both are not same. That means that unsymmetrical ethers. If you look at that, suppose if I'm taking this ether, so if you look at this oxygen, left hand side only 1 methyl group is there, right hand side totally 4 methyl group is there. Okay, that is what is unsymmetrical ether. So this method is employed only for the preparation of unsymmetrical ether. This is also used to prepare symmetrical ethers also, but the condition they should give. So here suppose they are giving some ethers, say for example a dimethyl ether or diethyl ether using Williamson synthesis. That time we can prepare it, but Williamson synthesis is entirely only applicable for unsymmetrical ethers. Okay, right. We can also prepare both the things, but the Williamson synthesis is only made for unsymmetrical ethers synthesis particularly. Suppose if I am taking alkyl halide, there should be a 1 degree alkyl halide. And alkoxide I should take. What type of alkoxide? That should be a 3 degree alkoxide. So I think so you find out, able to find out the degree. So if you don't know about this concept, please go and watch my previous videos like SN1, SN2. In that video, I'll be giving the how to identify the degree of that particular carbon. So here it is CH3, here it is 1 degree alkyl halide and 3 degree alkoxide. Okay, that time I'll be getting the product like this. What is that? So one ether, that is unsymmetrical ether, I'll be getting. Are you able to understand, students? Suppose instead of that, if I'm taking this as 1 degree, this as 3 degree, that time what happened? So you can't able to synthesize the unsymmetrical ether. Instead of that, you may able to synthesize alkene as a product. So please keep it in mind. So we have to use alkyl halide as a 1 degree. So alkoxide as a 3 degree. So alkyl, alkoxide. So 1 degree, 3 degree. So IAL, KYL only 5 letters. Alkoxide 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 8 letters. So you can remember it. Alkoxide, that should be taken in 3 degree. So you just make it as a clue or make it as a trick. So here it is a 8 alphabet is there. That's what it may be called as. What is the 3 degree you should take? Okay, that's for your remembrance. Just I'll be giving the clue. So here 1 degree alkyl halide. So we should satisfy this condition, or otherwise you will be getting formed. Suppose if I am taking reverse. Suppose if I am taking 3 degree alkyl halide and 1 degree alkoxide. That time I am unable to prepare this unsymmetrical ether. I can able to prepare only alkenes as a product. I think so you understand well. And next one is a Rosenman reduction. What is that? Very, very important reduction. It's a catalytic reduction. So here we are going to use palladium as a catalyst. That is what it will be called as a catalytic reduction. So here barium sulfate will be used to avoid the further reduction. So for that the sulfur is getting poisoned with the barium sulfite. So here, if you don't know about this concept, because here barium sulfate will be poisoned by sulfur, and this will be acting as a poison to avoid further reduction. That I will be tell you. Suppose if you don't know this concept, please go and watch my previous video in Rosenman reduction or any other part. So you'll be getting good idea about this. So here RCOCl, one acid chloride will be taken, and you are going to pass hydrogen gas. In presence of palladium, barium sulfate will be poisoned with sulfur. I'll be getting formed aldehyde. What kind of aldehyde? RCHO aldehyde is formed along with HCl is denoted. Suppose the R is what? It may be a alkyl group or it may be a aryl group. That's what I'll be writing as CH3 and C6H5. It is nothing but alkyl group or aryl group. Suppose if I am taking acetyl chloride, that time I will be getting acetaldehyde. Suppose if I am taking benzoyl chloride, that time I will be getting benzaldehyde. Okay, are you able to understand, student? So if you don't know about this concept, please go and watch my previous video about Rosenman reduction. You'll be getting good idea about this. Okay. Our next one is Styrenic reduction. It's very important one. Styrenic reduction. So Styrenic Synthesis. Yes, you can remember it. Styrenic reaction, it is only used to stannous chloride will be used. The stannous chloride with HCl will form this kind of SnCl4 with 2 hydrogen. That suppose here nitrile group is there. That may be a alkyl nitrile or aryl nitrile. Okay. So why here CN group? It's a cyanide group. Am I right? Right. Why it is called as a nitrile in organic compounds? Because if it is an CN is an ionic compound. If it is present reaction with KCN instead of R, suppose if I'm KCN, that will be acting as an ionic compound. K plus and Cn minus. But in this case here, it will forms covalent bond. That's what the Cn minus will not having that much of poison. That's what it will be called as nitriles instead of cyanides in organic compounds. So here nitriles will be taken. That will be reduced in with HCl. So I'll be getting some imine compound will be there. That imine compound can be hydrolyzed to form aldehyde as a product. Suppose if I'm taking acetaldehyde, so there is ethine, what is that? Ethyl nitrile. Ethyl nitrile in the sense 2 carbon atom containing nitrile group. That is the ethyl nitrile or methyl cyanide, what it may be. Okay, so here methyl cyanide or ethyl nitrile will be taken. So that will be reacting with these component in presence of what is that? HCl. I'll be getting some intermediate. That intermediate is getting hydrolyzed. I'll be getting aldehyde as a product with along with that evolution of ammonium chloride. Are you able to understand, students? It's very simple one. Styrenic Synthesis. You can remember it. And next reaction is ETOD reaction. What is the ETOD reaction? So ETOD reaction is nothing but a chromyl chloride reaction. So here toluene will be taken, or methyl benzene will be taken with a chromyl chloride in presence of a carbon disulfide as a solvent. By that way, I'll be getting some chromium complex. That chromium complex is getting hydrolyzed. That time I'll be getting aldehyde. So here is nothing but one hydrogen is there. Instead of that, I'll be writing. So and one O is there. The hydrogen is getting removed and O is directly joined with this. I'll be getting formed the chromium complex. If this chromium complex is hydrolyzed, I'll be getting benzaldehyde as a product. I think so you understand well about the ETOD reaction. And next one is a Gattermann-Koch reaction. This is also very simple one. So here, suppose if I'm using benzene or its derivatives will be taken, carbon monoxide and HCl in presence of anhydrous aluminum chloride or copper chloride, cuprous chloride I'll be taking. So I'll be getting formed a benzaldehyde or substituted benzaldehyde. So this is nothing but a Gattermann-Koch reaction. Are you able to understand, students? So I think so you understand very well. Thank you so much for watching. Please go forward to others to get benefit and don't forget to subscribe my channel. Thank you so much for watching. Thank you once again. Thank you. Thank you for learning. Share and like this video.